we continue calculating. Now in B, we want to show what I've written up here. And basically we can just continue from A. So let us do that. Let's just say this is equal to star. And we have that star is equal to the integral from u to infinity and then the integral from log x to infinity. And what we do now is instead just take the integrals from 0 to infinity and 0 to infinity and move all the boundaries inside an indicator function. And the indicator function we have tells us that x should lie between u and infinity, and y should lie between log x and infinity. And then we do have the density that also needs to be written. E to the minus y minus m squared divided by 2 sigma squared dy dx. Okay, well, since we've got this thing here, let us try to consider this set on the side. So we have that u has to be smaller than x, which has to be smaller than infinity. On the other hand, you also have that x has to be smaller than e to the y, smaller than infinity, due to this second part of the indicator. So x must be smaller than e to the y, must be smaller than infinity. And apart from that, you also have that x is greater than u. So this is the information that we gain from this here. And when we want to interchange the order of integration, we want to integrate first with respect to x, then with respect to y. So you want y to run from something to something else. And then you want x to run between values that depend on y. Here we can see pretty clearly already that x is going to be bounded by u and e to the y. So x must be greater than u and smaller than e to the y. What about y then? Well, we can see that y must be greater. Well, first of all, y must be smaller than infinity. So we have that one. However, y must be greater than log x. And you know that x must be greater than u. So therefore, another thing that we should note is that y should be smaller than infinity, and y should also be greater than log of u. There we go. So now we have taken care of the indicator, and we have switched the order of integration. And the only thing we need to do now is to figure out what to do with whatever is inside here. So what we have is 1 divided by square root 2 pi sigma squared multiplied by e to the minus y minus m squared divided by 2 sigma squared. I think I've written the dx dy a bit too far out, so let's just move it in. What we want to do first is integrate with respect to x. And what you see is this entire term here is constant with respect to x. So in fact, you can just move it outside then you have e to the minus y minus m squared divided by 2 sigma squared. And when you move this entire thing outside of the inner integral, then the inner integral is just an empty integral over 1 from u to e to the y. So that is just equal to e to the y minus u dy. And was that what we wanted? I think that was exactly what we wanted. Yeah. Okay, so if you're one of those people who like to have a bit more, you know, a few more calculations, intermediate into a few more calculations, then you could probably also write, you know, 1 divided by square root 2 pi sigma square e to the minus y minus m squared divided by 2 sigma squared there, and then write something along the lines of, well, x is the antiderivative of 1 u to e to the y dy, if you insist, because that's also fine. And then you arrive at the answer.